Okay, we have finished the calibration of 70, 60 and 45 degree probes. We set the transfer correction, DAC curve. So now in this video I will go through all the steps that I would do when I get the task to check some piece of metal. So I'll show you step by step what's the process of me. I would work in this way. Okay, now what you need to have is the machine, cables, probes, maybe both calibration blocks in your where you go to work to recheck. Also you need this thing, the straight probe, the normal probe, the 0 degree probe, but I didn't do the calibration, so I'll just show you what you should do with that. Then I'm not fresh already. Ruler and cleaning stuff. Okay, so just let's move. Let's move. Okay, so what's the start? My boss comes and gives me a piece to check. He says, take this and check. Okay, with the UT. Okay, that's not the best view, but I cannot do more for now. So what's the standard, what's the criteria? I have no idea. Just do your work. No, I have no problem. I don't read your stuff. Okay, so if this is the case, then what I do is do the strictest possible checking from the standards, because I don't know what he will tell me tomorrow, what kind of checking I need to do. So what I'm doing is the strictest possible. So I will take the standard and check. What I need to do first is like take this and measure the thickness. The thickness is 12.3. Okay, and I'll take the paper and I'll write. The thickness is 12.3. Okay, I'll measure it in several places. So that's 12, that's 12.7, 12.07, 12.11, 12.19, 12.30. Okay, then it will be like 12 and thickness near the weld. Okay, there is the measuring thing. So here I have 12.12 and 12.4. So it will be 12 then, not 12.3 but 12. Now I will pause this. Okay, so I take the standard 17,640 and I'll check. The strict one is B, testing level B, and the thickness is 12. So what the standard says is to use to one angle beam, one angle. Okay, I will do with two just to demonstrate, but the standard says it's okay to check with one angle. Okay, now another thing is probe positions A or B. A or B is up or down. So I can do whatever I want and I don't know, I will check from this side, so from A. And what I need to do is total number of scans. So total number of scans is A1 and A2. A1 is this one, A2 is this one. Because I'm using only one angle from A side and I need to do 2 scans. What I will do to demonstrate is use 2 angles from A side and do scan A1 with a 70 and A2 with a 70 and the same one with a 60. But about that later. So that's what I will do. Okay, for demonstration purpose I will do that twice. After that, what I do is I take the standard 11666 and I check what duct lines should be used, and these are the same ones that I already wrote. So for the thickness from 8 to 15, acceptance level 2. So we are scanning B2, B and acceptance level 2 for 8, 15. That is -4, -8 and -14. That's what we have. The stricter rules, not the B3 but C3 but B2 or A3. Okay, doesn't matter now. My brain is already half frozen. Let's move on. 7 minutes. What I do then is, my job is, I will pause and take the gloves. At the moment my job is to do UT. Somebody took this piece and did the analysis of visual testing, checked everything both sides and is writing the paper. Then after that another colleague took it and made the empty on it, sprayed all the things on it, took photos and measures and is writing about indications with empty. I don't care about these things. I'm doing the UT task now. Okay, so other people do other things, I need to do UT. So what I do is I clean that. I will put a light on my head so you can see maybe better this piece. Okay, what I need is a clean surface, and I have, okay, I have 2 cameras now. Here you go. Maybe you can see something. I have some things that are not clean here and I cannot move through them my probe well. Okay, so I just clean the surface so it's good enough with such a thing. Then you take such a thing and you clean it once again, or use some machine for that. Okay, now what you do is you take this thing and you clean that also. Here you go. Now pause. Doesn't work. Maybe I need a number, maybe I need something, so I will write a number and it will be a piece that will be called Sunday, and then that will be A1 and that will be A2, and I can draw on another piece of paper the picture, because I will need that, because I know that I will find something. I don't know exactly the centimeters because I stuck what? tape on the other side. There is something there, but I cannot remember exactly. Okay, so that's the piece, and I will mark. Okay, we need a 0. We can put a 0 here. That's the 0. And that's the 0. Let's see here. Let's say that's a piece of the welding examination of some kind that was done 2 years ago, or maybe yesterday. Okay, so the surface is clean. What I need to do is switch the machine on. Now take 2 cables. I'll tell you and then pause. Take 2 cables and put the probes for transfer correction. Here you go. I have 2 probes for transfer correction, and I have, what else? Everything. Now what I need to get here is the transfer correction, or no, I will go to the big menu and put on the transfer correction and recall the data set. VCL, no, I have no idea what that is. Transfer correction duct, enter, and unfreeze. Okay, now I put on the gel. I can do that here, because I will put gel on it, so I can put like this, I can put like this, I can do like this, whatever I want. I have not done one part. I have done it, but in my head, not, you don't know about it. Here is the thing that I have not done. The thickness is 12. I need to clean 10 centimeters for the 70 and 8 centimeters for the 60. I am using 1 or 2 probes. So I'm using the first one 70. It's green here, if you can see. And the second one that I want to use for demonstration purposes is 60. Okay? The cleaning area is 10. This thing is 14. So what I will be working with is like scanning to here and to here, not all the way. I don't need that. So this is where you choose the probes. If the thickness is like 30, you choose the 60 and then whatever you want. If the thickness is like 50, you choose the 45 and okay, that one then. Okay, so the logic is like this. That's why I wrote 70 and 60. If I want to use 2, or I need. Now I need to use 1, but I will use 2. Okay, that one I have left out. Now transfer correction. I have found my ruler, a long one, so I'm putting it here. I'm putting the magnets on, and I'm taking the probes, I'm putting and now I want to see something on the screen. I need to put in the thickness. The process is like this. Okay, thickness. Okay, the lines were here already, so that's done. The thickness is in big menu, and the thickness of my metal is here. I can do like 12 and 0.5, but no use of that. So it will be 12. It should be maybe according to your documentation that you got with the metal piece, but If you don't have it, then you measure it and then you put whatever thickness is here. Enter. Okay, now range, that's too big. We don't have 30, we have the maximum of 14, so that will be 24. Good enough. We do transfer correction now. Okay, that's higher than I have, so I'm doing it, and I don't have the what? The gate. So I need to have the gate, and okay, that's 0 then, because I cannot, okay, that's still 0, so that's good enough for me. 0 is good enough for me here. So, okay, that's the same thing here as, okay, I can check on another side, but I don't think I will find anything else. So, okay, I found something more. It depends on how you turn the probe. Okay, that's higher. Then I need to have the gate. And then I go down, and then I go to the gate, and then I go back, and then I see that I have too much sound. Sound is too high. Here it's, oh yeah, okay, 1.7. Transfer correction 1.7. It's minus. I need to make it smaller. I will put it on another side, or maybe I'll do better and do it in the direction that I will be scanning, if I have enough space on the side. Okay, what I can get here is, yeah, higher than what I have. It's 1.5, whatever. So the sound is going through very well here, so I will 2.6, if I, yeah, I can find 2.6. So 2.5 then. Transfer correction, I need to make it smaller. 2.5. Then I will put that in the duct that I will set for the 70-degree probe. So that's how you do the transfer correction on your metal, because you have no idea how it behaves. Okay? Pause. Now what you do is you disconnect what you don't need. I need the green one, so I am disconnecting the not green one, and because we are checking when one probe is connected, here it's 70 degree, that's the one with the number, I have the duct for it. I'm going to the big menu. I'm taking the files. I should not be in a hurry because I will do it twice. .383. Enter. Now I will put in transfer correction. Duct, no, up to the side to the first offset. Once again, not this button, up. Yeah, the brain is already frozen. I should not do that. Let's do that slow. Up, to the right, up, to the right. Now I need to make it smaller. So if I have something, I need to make this smaller. No, that's bigger. Okay, 2.5. Here you go. Let's make it 2.6. I have put in transfer correction for this piece. Home. Down. Home. Now. Home. Here you go. Now I need to put in the thickness because this thickness is not right. Let's go to thickness and put in 12. Home. Now the range is too big. This is okay. Now I need to look at all the... Okay. What I can do also is just take the block and check if it's working well. But I have already put the transfer correction, so it can be not to the line. Here you can see that it doesn't reach. Okay, one more. Here doesn't reach, so the transfer correction is working. Okay, but I can see the hole, so it's good enough here. Here. So okay. Now I need to put some gel on here, and I need to spread it on the scanning surface. I won't be scanning, let's say, 2 centimeters from each side, because it's according to the welding things. There can be a lot of things down there and down there, but it doesn't matter for us now. What I do now, that's the 70-degree probe. After that, I'll do that the same thing with the 60. I just move it. Okay. I just move it like this. I need to draw it for you. It's from the standards, but what you do with the piece is you move the probe straight, okay? But still you should move it in the way that's 5-degree angle, and that you take some part from the last scan. Okay, so if you are scanning like this, so you should put it like this, then near it, okay, and then scan like this. Also you can wiggle the end, but this is how you do, and this is what you are looking at in the screen. You should scan but not look at the metal. Okay, I'm looking at the screen because I need to see what is in the screen, and this is the bottom and this is the top. Okay, you understand that if there is something here. This thing is at the bottom because it's the gate should be where our indication is. Okay, so here our gate should be somewhere here, so that, and the width we can increase a bit like this, so that when we have a spike we can see where it is. Great. Now down range, here you go. So if I find something here, I can see that the depth of this thing is 12. It's at the bottom there. Okay, now if I find something here, it means it's at the top. Yeah, because, well, that's legs. Okay, so I'm starting from the A2 and I'm scanning 10 centimeters. I can do 14, doesn't matter, but I'm just moving around, and when this graph crosses the evaluation line, the bottom one, that's where I need to check what is there. Yeah, that's the start of something there. And I should check it more, and I see that there is nothing. There is some kind of spike, a small one, but I cannot find anything. Okay, here something in there, but that's too small. Okay, I'm just scanning, and let's see where I can find something. Okay, scanning. It's not clean enough. There is something on there, but okay, and then I have a problem here. Okay, here. So I take the marker and I put it a dot here. Let's see. Here is a problem that I have. Okay, you see that it's going through the roof and it's like in the middle of the line, so it's at the bottom. Okay, now the start is, let's say the start of this thing, okay, it's here, so it's like here, the starting point that we need to cut. If that's a bad thing, then the indication goes up, then it goes down, it goes up, it goes down, it goes up. I'm moving the probe to near me. It still goes up, it still goes up. There is the same indication in the same place. I'm moving to near me. Okay, and I'm almost at the edge, and now I'm at the edge. There is no metal for me to check now. So this indication that I found here is from the edge to here. Okay, now I'm checking from this side here. You can see now I will go down, okay, to check all the lines. Okay, and here is the indication. Yeah, this one. I'm going, and here is it. Well, it crossed this one, so it's bad thing. I cannot allow that. If it's like here, I cannot allow that. If it's here, I have to record it. Okay, so it's through the roof. If it's through the roof, I can guess that there is a 90-degree angle there, because it reflects almost all the sound back to me, like a corner. Okay, so I'm doing it once again. Here is something else here. Okay, here, but it's on the top. Here, okay, here. And well, the weld is not great because it has this gap here and the sound goes, I have no idea where. Okay, but it's not through the roof. This indication is like how high. Okay, it's over the recording level, but okay, it reached the acceptance level, so it's another defect that we could analyze. Okay, but what I want to check is this one at the bottom that I have glued the paper on. Okay, so that's the start, that's gone. Okay, and then I'm checking, and down there is nothing here, you can see. Yeah, now I'm checking the other side because it's A2, half an hour. Okay, I'll do that faster maybe. I'm checking. Okay, that's white already, not great. I didn't. Okay, I'm doing that the same with a 70-degree probe, and here are the things also somewhere. Here you can see some kind here. Okay, in the middle, it's the bottom, the top is completely in the middle of the metal of 12 millimeters, and here is 6, so it's 12 here, and it's with a second leg. Okay, I can check it. Okay, so if I want, I can check 34 millimeters from the front, 6 in the middle, and that I cannot check. So 34, where is it? Well, that's in the middle here. In the middle of the weld, here is an indication at 6 millimeters depth. Okay, so okay, I can also mark it with a marker or with something. There is a problem in here. I cannot see it, so you cannot check it because it's in the middle. Okay, now here it goes, still goes on, goes on, goes on, goes on, goes on, and when does it disappear? I have no idea. It should disappear somewhere now. So it goes, okay, through all the length. Okay, here you can see that it's still there, and I'm already at the edge here. From this side, you could not see that from the other side, but if the weld is like this, I'm checking from this side, and this indication might be there on the weld. The weld is like this, so it's not great, and it's dead. Okay, so we have a problem here, and we have a problem, I think, here, but well, I can, or if it's welded like that, maybe it's in here because it shows in the middle. Yeah, so from the end it's still here, you can see, and I'm going, checking it, and I still need to check that, and when it ends here, there is something. Okay, so it's through all of it. Okay, then, yeah, here is also an indication. So, okay, from that side, it's in the middle. It's not at the bottom. Can I find something at the bottom? Here is a problem at the bottom. Here, you can see. And here is the problem. No, I cannot. Okay, here is a problem at the bottom. I need to move the probe closer to get the problem at the bottom. Here, 12. Okay, here it's 12, a big problem at the bottom. From that other side I'm checking. Okay, so the place is here. Okay, here is a problem at the bottom. Here is no problem at the bottom. It's clean here. Okay, so the problem at the bottom starts here. Here, it crossed the bottom line. Okay, here is what I marked. So the problem at the bottom starts from here and goes there. Yeah, there is one problem here. You can see that this problem is at the bottom. Okay, so from both sides I can see this problem from the bottom. Now from this side I can see a problem in the middle through all the weld. But I will take the tape and I cannot see in the middle, so there is a problem. How can I show you this problem? Okay, so the problem, another one is, okay, what then I do is I take the paper and I mark, okay, from the bottom, from the 0, that's 70, so it's 70 and length, and the depth is, well, 12, but where it starts and where it ends, okay, it starts, let's say here, so it's 12 and a half, then it gets bigger, and then it ends, yeah, okay, here 9. Wow, electricity is finished. Well, that's nice. I can do that. Okay, no, not this one. Wait a minute. Okay, I have put in the charger. Yeah, it shows 0 degrees, so okay, let's do, okay, so I was trying to find from this side the start and the end. So the start is here, okay, let's say it's 9.8. The indication starts, let's say, here, okay, from 9.8 starts, okay, here it big, and then where it ends, well, let's say here 8, so from 8 to 12. Okay, now another problem is in the middle, so it starts from here, let's say from 8, and then it goes up, and then it ends never at the top. Yeah, that's at the top, so it starts 7 and then it ends at the top. Okay, there should be some cracks, so I should, if I do the empty, I think I can see it, but that's another experiment. Okay, okay, there is a problem there. Okay, and here it starts, yeah, it is, yeah, it's not at the top because it's not going through the roof at the top, so I might see it, or I might, here you can see that the start is like here 9, then it goes up, and then it disappears at 4. So from 9 to 4, now it starts here, so it's 9 and then up and then down 2. Okay, so yeah, here it starts from 9 and ends in 2. So this one is from 9 to 2, let's say. Yeah, that's the process. Here is the start, here is the middle, and here is somewhere it ends 2. Yeah, and it goes through all the weld. Another indication. I want to check in the middle here. This, okay, and we need the decibels of this indication. So I need to write down of this one. That is at the bottom. I will check. I think I won't do the 61, or maybe I'll do another one because it's enough. I found a defect and it's not a good piece, so I don't have to do another thing with the 60 degrees. 70 is enough. So, but I need to take the decibels of this indication that is at the bottom, and the decibels will be the highest here. I have found something here, okay? That goes through the roof and doesn't show anything. So it's plus 9.9. This indication is plus 9.9 dB. Can I find more? That's 6. No. Okay, the end is not that great, but that's 9.9. So, well, okay. From the other side, I'll check this one. What I can find here. It's still like here, like plus 2.5. Okay. Now, what I can find from that side, higher, something higher. No, that's not too high. It's to the line, so it's like plus 1, plus 2 and 7. Okay, and that's gone. Okay, so here is the start. It starts shooting through the big line, but from this side it's not this bad. And as you can see, I cannot, from this side, I cannot see the other indication that goes through all of the metal. It's completely empty here, you can see. Only this indication. From that side, when I start here at the bottom, you can see this thing, and it goes through the roof in one place. So it's like here. Okay? Okay, that was 10, so it will be 10 good enough. Now, but if I scan from this side, you can see here the problem, and here from that side there was nothing. Okay, so I will check the decibels, the maximum. Okay, so okay, here, okay, 4.5 is good enough. Let's check what I can find more. What I can find more. My gel is already not working. Okay, so here, it's here, it's here, it's here. I will increase that because that's the way you should not work. If the indication is on the second leg here, you should increase it, and then here you can see that you can see it clearly now. So, well, now it's 2.4. I will write it down. Plus 2.4. Now what else? Something more? Okay, that's 5. Okay, something else. Okay, that was high, but yeah, 5 is okay. Yeah, 6 already. If the second line is crossed, okay, that's a bad thing. So if this line is crossed, we don't look at the standards, how much, what indication, because it's already a bad thing. Okay, but if it's down there somewhere, you need to check. Well, maybe I shouldn't say so. You should check each time the standards. Okay, so you should read the standards and do what they say. But if it goes through the black line, that's, yeah, you just defect that. Okay, +6. So through all of it goes a indication that is from 2 to 9 millimeters deep and +6 decibels. And from here the indication is at the bottom here, and it is +10 decibels. Okay, well, if you need a paper to report, then you mark it like this. One is indication is, this one is 1, and then this one is like 2, and the length of it, the x is like this, but x is here, length of here, and you just mark it on here for the welder to cut and re-weld. Already my brain is not working, so I think no more videos for today. Now, what I need to do then? Okay, what I need to do then is check the bottom, because I cannot check. Maybe I'll put the 60 and check for 5 minutes, and then we'll check the bottom. If there is an indication here, how long? 70 millimeters. Okay, let's do the 60. What I do is I disconnect the 70. I take the 60. The transfer correction is 2 megahertz here, so it doesn't work, but I should have in mind that transfer correction was -2. The spike is too high, so I can have it in my mind. Okay, now I go to the main menu. I take the 60-degree probe duct. I put unfreeze. I put in the thickness, and that is 12. Now I decrease the range. Here. And I check with the 60. Okay, now I'm checking from the A2, and if I can see something going through the black line, okay, I'm checking here and I'm checking here. I'm not looking at the third leg. 1 leg, 2 legs. I don't know what that is, so just leave it as the noise or something for now. Okay, that's maybe not the noise. It's in the middle, so maybe where we don't have the gate. The gate should be somewhere left in the beginning, because we are using it here. It should be somewhere here. Okay, and it shows that, yeah, this, let's say that's the defect. It reached the black line. The decibels is like 0, and the depth is 5, and it's 18 centimeters from the start. 18 centimeters, 20 centimeters is in the middle here of the weld. There are 2 caps here, so it's in the middle of the weld. Now I'm going down, 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 and here maybe there is a problem at the bottom, but I cannot reach with the 60. Okay, here is something, and it's in the depth of 9, 8. Here you see, yeah, it's 9, 8. Okay, here. Now here it disappears, so let's say that's the same thing. Now I'll check the other side. And here it's in the middle also. I can see some indication here in the middle, and it's 5 and it's 18 from the front. So yeah, it's in the middle between two welds here. Now still here an indication, maybe the decibels are better. 6.5. For this indication I have 6, so that's higher with the 60 degree. Here this indication is 6.5 already. Okay, so I can put in 6.5. Okay, here is an indication at the middle, in the middle. Okay, from this side here. Okay, maybe even higher than, yeah, higher than 7 already, and maybe even higher because the gate is already not in its place. But I cannot reach this bottom with the 60 now. You can see that I have put the probe to the weld and it doesn't reach it. Okay, so I cannot check the bottom, exact bottom. Okay, I will try to get with the third leg, but you should not do that. I want to see it there. So range, let's make it bigger. Range, and maybe I can find it there, the bottom with the 60. It should appear here, but not here at the top, at the bottom, here in this part. So it starts here, maybe this thing, here, it's at the bottom, top and bottom, yeah, so there is something crossing the line, yeah, there. If it's crossing the line, then there is something. It should be complete here. Yeah, here is what I saw with the 70, but it's with the third leg what I am doing now. We are not working with the third leg. I'm just experimenting here. Yeah, this thing that is shooting here, that's at the bottom. But yeah, here. Here, this one. Okay, here. The problem is they're down there, but okay. 53 minutes. Let's check the bottom now. I'll pause to clean. Okay, we don't need the machine now. So I have moved the camera here just to, maybe you can see something with it. Okay, not that easy, and maybe not easy at all. I hope it will be easy to take it off. Okay, now let's put it aside. I'll take the phone, maybe I'll show you if I can. Okay, what we have here. So what we have here without the light, or maybe with the light, okay, is this. Okay, here is the weld at the bottom. Okay, maybe this way. No. Here. And what we have is not enough metal in here, and then later that's fine. There is nothing that we can see here. Okay, yeah, you can see that it's quite clean and nice, and this problem starts somewhere let's say here. If we need to clean it, we should clean it so there is no problem, and that's where we should start, here or here. Okay, we have a problem here. Okay, now we need to take the ruler, and I should have a white one so you can see something. And what we have here is like 7. If we found from there 7 is like here, yeah. If we check closely, maybe we can find 2 problems from that side, and maybe also in here. Okay, here is 1 problem from this side. Okay, and then here is another problem from that side. Okay, so, well, that's the problem. And what I have marked on the paper is 70 centimeters from here, and the decibels is +10. +10 is this thing, okay? When there is a 90-degree angle, like a corner, it goes through the roof, okay? It's not a pole, it's not a round thing, because our dark block here is round, okay? So our graph shows a round indication here and here and there, okay? That's round. When it's not round, when it has a sharp corner, sharp edge, that's when it goes through the roof. Okay, so okay, I can show you this indication, but I cannot show you this one because it's inside. Okay, if my colleagues broke this one with destructive testing we have here, then we can find something here, or with RT, okay? But with UT I can tell you that there is another indication in the middle. Wait a minute. In the middle, that is going through here, and it's from, like, I have marked like 2, from 2 to 9 depth. So there is something in here also that is not great. Okay, so this is the way I'm then writing that down, this thing. Okay, and that's my result of UT testing of this piece. With 70 and 60, they show little bit different things, as you saw. So that's why if you have according to the standard, to do it with more angles, then you can find more things. 59.5 minutes. Hope you found it interesting and useful, and have some knowledge about how to do that. My phone, this one is not recording, so I have no idea when it stopped. Okay, I will check, because I have no idea when it stopped. I clicked something, so maybe I will need to do something after that. Okay, I'll check. So I'll do maybe another test with another thicker metal with a 70 and 60, or maybe it will be 60 and 45. And that's it for the working with the angle probe and with the USM Go defect flaw detector. Bye for now.